conclusions. If hypothesis, then conclusion, and then after that is the implications. This one is the logical operators. Is a symbol or words that being used to connect two or more expressions, such the value of the compound expression produced depend only on that of the original operation and on the meaning of the operators. Common logical operators include and, or not. This one is logical operators. What are the 5 logical operators? If you ask me, they have the 5 logical operator symbol. We have a tidal, dot, wedge, horseshoes, and triple bar. This one is the 5 logical operators. And then we have a logical AND operators. That returns the true values. And so on. This one is basically we can have a 3 basic structure. First one is the hypothesis. Then we conclude, and then we have the implication. What is the truth value of the proposition? It's probably a false, and then you can see here the symbol of implication is the arrow. This one is very important. For the hypothesis, conclusion, and implications. If you have any question, you can ask in lecture session, because this one is just to enhance your understanding. This one we can have a biconditional. Is this statement x less than y if and only if y is greater than x. You can see the biconditional. You can have both arrow, left and right. Is this a propositional? Yes, because the truth value does not depend on the specific values of x and y. What is the truth value of these propositions? If you can see here, we have AND operators. We have x and y if and only if y is greater than x. It is true. This one is very important. We have the biconditional operators. If you ask me what is the example of biconditional statement, if I have a paid good, then my homework will be eaten. If I have a triangle, then my polygon has only 3 sides. If the polygon has only 4 sides, then the polygon is a quadrilateral. If I eat lunch, then my mood will improve. They have both statement, which one statement depend on another statement. It is based on the true and vice versa. This one is important. A biconditional statement, I repeat again, is a logical statement that include the phrases if and only if, sometimes abbreviated as IFF, if and only if, IFF. We see another one. This one we want to combining the propositions. As we can see before this, we have the proposition, and then we have biconditional proposition, conditional proposition, and biconditional proposition. And then we see the previous example one more proposition can be combined to form a single compound proposition. Compound proposition. Okay, compound proposition is the conjunction is compound proposition which consists two propositions joined by the connective and. Okay, this one I repeat again. Okay, we formalize this by denoting the proposition with letters such as P, Q, R, and S, alphabetical, and introducing several logical operators. Okay, later we see this one. Okay, example. Okay, please bear in mind. We have here. We want to combine or to join with the connective N. Okay. Here we have today is January 25 and 99 is less than 5. Okay, we can see here P today is January 25 is proposition 1. And 99 is less than 5 is proposition 2. And then we have logical operators and okay, and then we have mathematical expression P and Q. Okay, this one is compound proposition. Again, this one is the compound proposition. Okay, bear in mind again, compound proposition is we want to combine two propositions joined by the connective N. Okay. Okay, and then we go again by the logical operators. Okay, logical operators. Okay, we can have the connective. Okay, we can see here we have certain symbols for negation, not, for conjunction, and okay, for disjunction, or okay, and exclusive XOR. Okay, we can see the symbol there, and then we can have the implication. The implication that we have discussed in the part 1, if then. Okay, and then we can have the hypothesis. And then we go for the conclusion. Okay, and then again we can take a look for the biconditional. Biconditional again is the statement that depend on one another, that being true or vice versa. Okay, look at the arrow for the implication and arrow for the biconditional. Okay, the truth table can be used to show how these operators can combine proposition to compound the proposition. To compound, which means to combine. To combine, or another word is to compound. Okay, we take a look for the first negation. Okay, we can have the unary operator. Bear in mind, unary operator is the single operators. And the symbol is for negation is like this. Okay, if we have the truth table like this, okay, we have a P is true, and then we have a negated P is false, and then P true again, and then when we negate the P is going to true. Is the either way for the negation. Okay, sometimes in mathematics it is very important and very crucial to determine what is opposite of a given mathematical statement. This is usually referred to negating or negation statement. One thing to keep in mind is that if the statement is true, then its negation is false. And if a statement is false, then its negation is true. Okay, again, how you negate? The negation of P, okay, is the statement when the opposite truth value as a negate P. Here we can see the negate P symbol. Thus the negation, if we have two symbols of negation, negate P and negate P is just another name for P. Okay, the negation of P and Q assert it is not the case that P and Q are both true. Okay. Okay, later we see another lecture for this one in part 3. Okay, thank you.